Have the great name of Allah is the most kind and merciful. Assalamu alaikum. This is Yasin from the Department of Computer Science, batch 2018. In this video, I am gonna present a final term presentation of software engineering. So here's the agenda. These are the topics that I will cover in this video: software development lifecycle, software crisis, spiral model, and software evolution. What is software engineering? It is an engineering branch associated with development of software product using well-defined scientific principle, method, and procedure. So software engineering is all about to create a systematic software. Software development lifecycle, which is also called SDLC. It is well-defined structure sequence of steps in software engineering to develop intended software product. So it is a process to develop a software by some steps. So these are the steps to be followed to design and develop a software product. Number one is planning. Number two, analysis. Number three, designing. Number four, implementation. Number five, testing. Number six, maintenance. So these are the steps that we follow to create a systematic software. So if we done first phase or first step, then you can only go to the next. So it means that the first step output is the next input of the next phase. Planning develops a project management plan and other planning documentations, provide the basis for acquiring the resource needed to achieve a solution. So we can say the SDLC is a well-defined series of steps that is used in software engineering to develop efficient and reliable software for one particular client. So before the development, we plan that how we going to make the software, what model we will use, what are the client's requirements. We communicate to the client that these are the things done in this phase. After completion of this phase, we will go to the next one, that is analysis. So analyze user needs and develops user requirements, create a detailed functional requirements documentation. So in analysis, senior developers analyze the client requirement as well as system requirement for estimate the cost, main workforce, and the duration of the project. After the analysis, the they write everything in a document that is called SRS, Software Requirement Specification. Number three is design. Transform detailed requirement into complete detailed system designing documentation focuses on how to deliver the requirement functionality. So after the analysis, we going to the design phase. In this phase, developer design the database function, procedures, and algorithm by UML. It creates classes, etc. Then we go to the implementation phase. Converts a design into a complete information system, include acquiring and installing system environment. So this phase is actually main and physical things happen here. Implementation refers to coding. Everything which we had written, now it's time to make into reality, from software design to backend development. Number five is testing. Demonstrates that the developed system conforms to requirement as specified in the functional requirements. Documentations conducted quality assurance staff and user procedure test analysis. If the product is developed, now it is time to test it from various testing techniques. Example, unit testing, module testing, integration testing, black box testing, white box testing, etc. Number six and final stage of SDLC, there is maintenance and deployment. Describe tasks to operate and maintain information system in a product environment, including post-implementation and in-process devices. If our product tested successfully and there is no bug in software, then it is ready to launch or deploy in client system. So by the passing of time, client may want to add some new features so that it comes in this phase. There is maintenance. Topic number two, software crisis. So what is software crisis? Software crisis is a term used in early days of computing science for the difficulty of writing useful and efficient computer programs in a required time. The software crisis was due to the rapid increase in computer power and the complexity of the problem that could now be taken. So as you can see, these terms was used in early where there no concept of software engineering. There was a hard to developer to estimate the budget, cost, time, and the workforce. So these are some causes in a diagram: increasing demand, increasing complexity, increasing challenge. So for these three terms, we use the same workforce, same method, same tools. That will lead us a software crisis. So these are the causes: project running over budget, projects running over time, software was very inefficient, software was of a low quality, software often did not meet requirements, projects were unmanageable and code difficult to maintain, software was never delivered. So these are the crises that developer faced in early 1950. Number two is spiral model. So what is the spiral model? It is a combination of waterfall model and iterative model. Because the steps which is taken into spiral model is taken from the waterfall model, while the iteration is taken from iterative model. Each phase begins with a design goal and ends with a client reviewing. So these are the iterative. Software is developed in a series incremental release. So this is a diagram of a spiral model in which there are five phases: communication, planning, modeling, constructing, deployment. So before we going to make a software in software engineering, we use a spiral model in which we first of all communication, in which we communicate to the clients that what type of software, what is its budget, etc. After communication, we go to the planning. After planning, we go to the modeling and constructing and deployment. So these are the regions in a spiral model in which from communication to the deployment, the first region is completed. That is called a concept development. After the first regions, we go to the system development. That is second phase, second region. Number three, system enhancement. Number four, system maintenance. So these are the regions when to use spiral model. When project is large, when release one requirement required to be frequent, when risk and cost evaluation is important, when requirements are unclear and complex, when changes may require at any time for medium to high effort. So a spiral model is best used for large projects where the requirements frequently change and where the software become a complex. Advantage of spiral model. Additional free functionality or changes can be done at later stage. Cost estimations become easy. Development is fast and features are added in a systematic way. There's always space for customer feedback. Disadvantages of a spiral model. Risk is not meeting the schedule on budget. Documents is more as it has intermediate phases. It is advisable for smaller projects might cost them a lot. Number four, software evolution. What is software evolution? It is referred to as the process of developing, maintaining, and updating software for various reasons. Software changes are inevitable because there are many factors that change during the life cycle of piece of software. So, software evolution is all about how the software evolves, how the software changes. System types used in a software evolution. So basically, there are three types of system types used in the software evolution. There is first one is a static type, that is also called S type. Number two is practical type, which is also called P type, and number three is embedded type, P type. So static type are the software is a basic example of E type software is a calculator, and the P-type software are chess and gaming software. Embedded type software are inventory and banking software, etc. Layman's law software evolution. So these are laws are embedded type law. The law of software evolution refers to a series of laws that Lehman formulated starting in 1974 with respect to software evolution. The law describes a balance between the forces driving new development, developments on one hand and forces that slow down progress on other hand. Law number one, law of continuing change. This law states that any software system that represents some real world reality undergoes continued change or becomes progressively less useful in the environment. Number two, law of increasing complexity. As evolving programs change its structure, become more complex unless effective efforts are made to avoid the phenomenon. Number three, law of conservation of organization stability. For the lifetime of a program, the rate of development of that program is approximately constant and independent of the resource devoted to system development. Law number four, law of conservation of familiarity. This law states that during the active lifetime of the program, changes made in successive release are almost constant. So these are the factors of software evolutions, requirement changes, environment changes, error or security breaches, new equipment added or removed, improvements to the system. Thanks.